number 44, and topic for our project is Parkinson disease detection. So these are the group members for our project and the problem statement. So we are given a biomedical voice data in the form of CSV file, and we are to detect if a patient has Parkinson disease or not using this data file. So basically we have to classify data using different algorithms like KNN, SVM and random forest and compare their accuracy for classification. So these are the different algorithms used in our project. And so first one is support vector machine algorithm by Navdeep Kumar, KNN algorithm by Anush Solanki, modified KNN algorithm by Aditya Singh Gehrbar, random forest algorithm by Sandeep Singh, GMM unimodel classification by Himant Kumar, and Gaussian mixture model classification by Manik Agarwal. So these are the modules which we have imported in our Python file for proper working of our code. So I am Navdeep Kumar, roll number B21205. So here, first of all, we have declared the empty dictionary, which is global for storing the accuracy scores of different classification algorithms. So here we have imported the CSV files and performed the min-max scalarization, and then split the data set into training data, which is 70% of total data, and test data, which is 30% of total data. So first algorithm I have used is support vector machine algorithm. Support vector machine algorithm is the most popular supervised algorithm which is used for classification. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put up the new data in the point correct category in the future. So SVM chooses the extreme points that help in creating hyperplane. These extreme points are called support vectors. So in this support vector algorithm, suppose the data set is distributed in a plane. So first of all, it randomly plots a line in this region, and then it finds out the data points from regions which are closest to it. So here we can see this green point is closest to this line and blue point is closest to this line. So these points are called support vectors. So we first of all we draw the line parallel to our this main line passing through these points, and the ultimate goal of this support vector machine algorithm is to maximize the margin, which is the distance between this line and this our same main center line. So when we have found the line which is of maximum margin from both the data sets, then that line is used for classification. So we put our training data in the formula of this line, and then if it is less than 0, then we assign this class, and if it greater than 0 value, then we assign this right class. So here is the code for SVM algorithm. First, we have split the data into training data and test data. Then we have imported the inbuilt library SVC for fitting our data into the SVM algorithm. So it fits the our data into algorithm. So and then after fitting this into our algorithm method, it classifies the our data, and then here it is finding the accuracy score, and then for after the finding accuracy score, we have plotted the confusion matrix for this, which is in the form of heat map. This is our heat map for classification, which shows actual values and predicted values. And the accuracy score for this SVM classifier is 88.136%.
Hello everyone, now I am Sandeep Singh. My roll number is B21127. So I have contributed for the random forest algorithm. So first let me define what is a random forest algorithm. So basically random forest is a popular machine learning algorithm that belongs to the supervised learning technique. It can be used for both classification and the regression problems in ML. In our model, we have used it basically for the classification purpose. So it is based on the concept of ensemble learning. Now, ensemble learning is just a process of combining multiple classifiers to solve a complex problem and to improve the performance of the model. So basically, as the name suggests, random forest is a classifier that contains number of decision trees. Here you can say this is the decision tree 1, decision tree 2, and we can have any number of decision trees as per our required model. So the number of decision trees on various subsets of the given dataset and takes the average to improve the predictive accuracy of the dataset. And the greater number of trees in the forest leads to higher accuracy and prevents the problem from the overfitting. So here we can see that this is the training data 1, training data 2, and we divided the training data into subsets and then feed each part of the training data to different number of the decision trees and then compute the output of the decision trees. Then we take the average of all the decision trees and calculate the maximum output, that is repeated maximum time, and we predict output on that basis. So here is the code, the snippet of the random forest. Basically, first I have splitted the data frame into test data and the training data. The size of the test data is 30% and the training data is the 70%. So I have there I have used a classifier, that is the random forest classifier, and n underscore estimate is basically number of decision trees that we have used. Here I have used 40 number of decision trees, and max depth indicate the number of max depth basically indicates the depth of the tree that a decision tree that can have. And basically random state is just to randomly shuffle the data frames. Now I have fitted the my classifier that is declared above on the training data set, here X train and Y train, and after that I have predicted my values on the test data. After that I have calculated the accuracy score by using the accuracy score inbuilt accuracy score function, and then I have printed the accuracy. I have plotted the confusion matrix of the tested data, and here you can see the confusion matrix of the for the same. So this is basically a heat map that is, and I have labeled after that. So the accuracy of my model is 94.915%. Thank you.
Hello, I am Anush Solanki. My roll number is B211151 and I have written the code for the KNN algorithm. KNN works by finding the distance between a query and all the example in the data, selecting the specified number of example k closest to the query, then votes for the most frequent level. And for KNN algorithm, I have written four functions. First is Euclidean distance, which finds the distance between two data vectors. And second function is getClass, which computes the Euclidean distance of one data vector with all the training data vector and returns the most frequent class level corresponding to k smallest distances. And the third function is classify function, which returns the class of all the data set data using the class function one by one. And fourth function is computes the accuracy of KNN algorithm and confusion matrix for different values of k. And here you can see the confusion matrix for k equal to 1, 9, 5 and 13, and the maximum accuracy of the KNN model is 64.4%.
Hello everyone, my name is Aditya Singh Gairwar and my roll number is B21178. I have contributed in the modified KNN algorithm. It is similar to the KNN algorithm, but the only difference is that it uses Mahalanobis distance instead of Euclidean distance. Mahalanobis distance is a distance between a point and a distribution. As you can see the formula here, the mu represents the mean vector, then the sigma represents the covariance matrix. The benefits of using this distance are, as it uses covariance matrix, and so that if any two variables are correlated, it ignores them. It ignores the correlation between them. If we don't, and in this, we don't have to standardize the data like we did for the Euclidean distance, as the covariance matrix calculations take care of this. Here you can see the code for modified KNN algorithm. At first, I've split the data into test and training, where the size of training data is 70% and test data is 30%. We are calculating for values of k, different values of k, which are 1, 3, 5, and 7. First, we have used a built-in function k neighbors classifier and given metric as Mahalanobis distance, as by default it is Euclidean. Then we have fit the if we use dot fit function, which generates a model for this classifier. Then we have predicted for our test case, and here I have drawn confusion matrix with the help of heat maps. And then we have plotted a bar plot for different values of k. Here are the outputs of this algorithm for k is equal to 1, 3, 7, and 5. And by the bar plot, you can see that maximum accuracy is corresponding to k equal to 5, and its value is 74.576%. What we can interpret from these outputs is that there is no predefined statistical method to find the most favorable value of k. We have to initialize the value of k and start computing, and the value of k having minimum error rate or the highest accuracy is chosen. In our case, we get highest accuracy for k is equal to 5, so it is the most optimal value of k.
Hello everyone, I am Hemant Kumar. My roll number is B21294. I have contributed to unimodal Gaussian distribution algorithm. I have classified the data on the basis of Gaussian distribution. This algorithm makes assumption that data follows normal distribution. In this algorithm, we find the parameters of Gaussian distribution, which are mean and covariance metrics, using training data of the class. Then it finds posterior probability of class using these parameters. So basically this classifies the data set into different classes by fitting data set into Gaussian distribution for each class. Now I have written the code that firstly I have read the file, then splitted the data into test and training data, Then I have created data frames for different status, that is 0 and 1. Then here I have dropped the column which are useless. Next, I have find the covariance and mean covariance matrix and mean of training data for status 0 and 1 using the inbuilt functions. Then I have created list to store for storing predicted status of each test sample. Then I have find conditional class density or likelihood. After that, I have find the prior probability for classes. Then for class 0 and 1, P0 अगर if P0 is greater than P1, then I have used the status 0, else I have used 1. Then I have shown confusion matrix using the inbuilt function. The accuracy for this class is 86.441%.
Hello everyone, my name is Manik Agarwal and I have used the Gaussian mixture model for prediction of status. In Gaussian mixture model, each class is divided into Q clusters and each cluster has Gaussian distribution. For each class, we try to find the parameters for each cluster, mean, covariance matrix and mixing coefficient, such that the total data log likelihood get maximized. We use these methods for finding the parameters. Firstly, we initialize the mean vectors, covariance matrices and mixing coefficients, and then we use expectation step for finding the responsibilities, and according to that we assign the data points to the clusters. In the next step we find the next step is the maximization step, in which we re-estimate the parameters and use these current responsibilities for finding the new for finding the new mean and covariance metrics. And now we find the total data log likelihood using the re-estimated parameters. Now I will be explaining the code which I have written for the same. Here, firstly, I have defined the status column of the data frame. Now I splitted the given data into the training data and the test data. Now I divided the training data into according to the status for 1 and 0. Now I have computed the prior probabilities for each status. Now for the given value of Q, I have trained the model. Here you can see these are the Gaussian. I have built this model for the prediction. Now I have defined this list for storing the predicted status. Now I have computed the log likelihood probability using this gmm.score samples, and now I have converted that into likelihood for a status. Now I've computed the the posterior probability. Now and I have checked for the each state for the each state of the prior probability, and I have assigned for which the prior probability is more. I have assigned that status to that test sample. And now I have find this accuracy score, and here I have printed a covariance matrix with the help of heat map plotted, and here I have printed the accuracy score for each Q value. Here I have printed the accuracy score for the maximum for which I have printed the accuracy score for the cluster value of Q for which we get the maximum accuracy. And here you can see the outputs, and for you can see for the accuracy score for the accuracy we got the accuracy score maximum for the cluster value 3, and its value is 88.136%. Here now we have plotted the bar graph for all the algorithms that we have used, and here you can see the accuracy score. You can see that for the random forest algorithm, we have got the maximum accuracy, which is 94.915%. Thank you. I was Manik Agarwal and my roll number is B21200.